All right, 10.4. This is solving polynomial equations in factored form. So you know that factored form by now is you have something that you are multiplying by something else. So whatever's inside your parentheses is a factor because it's being multiplied by something else, which is another factor. Okay, anything inside the parentheses is a factor. Standard form is when it is written out with each of the separate terms. So that's a trinomial up there. That happens to be a quadratic equation. We're going to put equals 0 at the end because we are going to be solving. And when you're solving, we were looking, remember, for x-intercepts. So really that is somewhat like equals y. Changing the y to 0 means you would be on that x-axis and you would have an x-intercept. So we're going to figure out how to solve quadratic equations, remember, which have an x squared in them, but also how to solve other polynomial equations that happen to be in factored form. So we're just showing you that both of these are written in factored form. This would come out to be a quadratic equation, quadratic expression. If you were to multiply it back out, this would be a polynomial because you have three different factors. So when we say other polynomial, this is an other polynomial because you would not get x squared when you would multiply this out. How many factors does this have? Okay, so the top factored form has two factors because you see two different sets of parentheses. 2x minus 3 is one factor, x plus 5 is the other factor. On the bottom here, x minus 2 is a factor, x plus 2 is a factor, x plus 4 is a factor. You see three factors there. On the top, you're probably going to get two solutions to this problem. Bottom problem, you're going to get three separate solutions. All that means is when you graph something, it will cross the x-axis 3 times. You can goof around with that if you want a little bit on your graphing calculator on your iPad if you want to see if you can make graphs that would cross the x-axis more than 2 places. Show me what that might look like. Take a picture, send it to me. That'd be kind of cool. It says in this activity, you may have noticed that the product of two factors is 0 only when at least one of the factors is 0. This is called the zero product property. Here's what it's saying. Let's say I have the two numbers 7 times 0. What's that going to equal? 0. You get a product of 0 when one of your two factors is 0. That's just an example. So when I go down here, if I look at solving this equation, here's one of my factors is x minus 4, and my other factor is x plus 1. If I'm going to multiply those two things times each other and get an answer of 0, that means either oops, I have this written wrong. Woo, change your notes. Either the x minus 4 equals 0 or the x plus 1 will equal 0. And then you need to solve for x. So if I add 4 to both sides, or some of you just know what number that is sitting right there, but I'm not going to say it out loud, then x equals 4. That's one of your x-intercepts. Or same thing over here, what plus 1 makes 0? X equals -1. Those are your x-intercepts. They're your solutions. What's another name for those? Roots. X-intercepts. But you have solved that factored form. Okay, so when they show it to you as the square of a binomial, you can write it out the long way if you'd like. This just means x plus 8 times x plus 8. Solving it means you're setting it equal to 0 because you're looking for an x-intercept. It would be redundant to do the problem twice. So we're just going to say what would x equal? What number am I adding to 8 to get an answer of 0? Some of you just know this. -8 plus 8 makes 0, right? So x is -8. There you go. We solved that using factored form. All right, example 3 has how many factors? Looks like 3 factors. If I'm solving, I have to find the x-intercepts. I have to put this equal to 0. If you're multiplying 3 different things times each other and getting an answer of 0, one of them must be 0. So either 3x minus 2 equals 0, or 4x plus 3 equals 0, or x plus 4 equals 0. You will have, if there's 3 factors, you're going to have 3 solutions. If there's 2 factors, you're going to have 2 solutions. If there's only 1 factor, and I'm going to go back to example 2. Oops, sorry about that. This pretty much had 1 factor. It's just being multiplied by itself. So you get 1 solution. Okay. Back up to example 3. You have to solve each of these for x. So if I add 2, 3x equals 2, divide by 3, x equals 2/3. 2/3 would be one of my x-intercepts, one of my solutions. Sorry about that. Subtract 3, 4x is a -3. Divide by 4. X equals -3. 4 is another x-intercept, another one of my solutions. Subtract 4, x equals -4. I have 3 solutions on this problem. I have 3 factors. Let me show that to you a little bit better. You can take a picture of it if you need to. You're really just solving each set of parentheses for 0. Solve for x when that part of the parentheses equals 0. Okay, this might sound like a bunch of nonsense to you for this next part, but for any quadratic polynomial, that means with the x squared being your largest term, and it also needs to have an x squared. If one of the following statements is true, all 3 of these statements is true, or are true. All right, so they're saying that if this is a factor of that quadratic expression right here, okay, like that is a factor. For example, like x minus 4 and x plus 3 are factors of this. Then x equals p is a solution of that quadratic equation. So x equals 4, x equals -3, solutions to this equation. Then, like I've already stated this, but then p, the 4, the -3, are x-intercepts of the graph of that function if you were to graph it. I've said that already. So we're going to use this solving using factoring to actually graph a quadratic expression. I think you're going to kind of like this. It's going to be better than the other graphing because we don't have to do the whole -b/2a and make the table and put the vertex in the middle. It's just not as ugly as that. It's a little quicker. So step process, example 4. Sketch the graph of y equals, and then this is in factored form. Okay, in chapter 9, it was in expanded form. We're going to solve for 0 to find the x-intercepts. So either x minus 4 equals 0 or x plus 2 equals 0. If I add 4 to both sides, x can be 4, or subtract the 2 from both sides, x can be -2. Those are my x-intercepts. You know how to graph x-intercepts, okay? So these are actually 2 points that we can put on a graph. I'll graph it in a second. Finding the coordinates of the vertex. By finding the average of the x-intercepts. Okay. Your vertex is going to fall right in the middle of these 2 x values. So if I find the average of my x-intercepts, that means take 4 and add -2. Add your numbers together. And then divide by how many numbers you have. 1, 2. All right, that is the x value of my vertex. When I find the average of my x-intercept is the x value of your vertex. So really that one. Where is the x value of my vertex? How did I get that? Average these numbers. Or the number 1, if you look at those numbers on a number line from 4 to -2, 1 is exactly in the center, in the middle of 4 and -2. Substitute your x value of the vertex, that 1, back into the equation. This is just so much easier too because my equation, y equals x minus 4 times x plus 2. Remember the x value that I just got? That I just solved for? My x value was 1, so I'm going to put a 1 in both of those spots right there. So I'm going to put a 1 minus 4 and a 1 plus 2. 1 subtract 4 is -3, and 1 plus 2 is 3. The y value of my vertex is -9. Okay, that -9. My vertex is 1, -9. Okay, I'm just going to sketch a graph on here. What? She's not using graph paper, people. Something must be wrong. I don't have my smartboard. I can't drop it down. Okay, so here's the two things. We're going to plot these 2 points, the 4 and the -2. 1, 2, 3, 4. That was one of my x-intercept. It's a point on your parabola. We're going to graph the -2. -2. Okay? We're going to graph your vertex, which was 1, -9. This ought to be pretty. But 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, -9, way down there. Your graphs are literally only going to be those 3 points, your x-intercepts, and your vertex. Okay, so you're going to graph using 3 points. The 2 x values that make each of your factors equal to 0. So 4 and -2. 4 and -2. You found the x value of your vertex by adding that 4 and -2 together and dividing by 2. You're averaging them. We got 1. Put the 1 into the problem where you're seeing the x values. Solve it for y. And you got -9, and that was your vertex. All right, last example, example 5. You have an arched garden trellis. I don't know if any of you have them outside, like along your house, and you got like a climbing rose or an ivy or something that goes up your trellis. But an arched garden trellis, I guess, could look something like this, right? And it's got plants growing on it. Anybody know what I'm talking about? I have one, but it doesn't look like a parabola. So they're saying it's modeled by, and they give you this equation. Y equals -1.8 x minus 2 x plus 2. With x and y measured in feet, how wide is the arch at the base and how high is the arch? Okay, these are going to be like your x-intercepts. And how wide is it at the base? So when we solve this, we're going to say, what if this equaled 0? What if this were equal to 0? So if this factor equals 0, then x would be 2. If this factor were equal to 0, x would be a -2. So 2 and -2 are my x-intercepts. How wide is this arch at the base? Would be from this 2 all the way to the -2. So if you're thinking about it on a number line, 1, 2, 3, 4, they would be 4 feet apart at the base. okay? The how high is the arch is actually going to be the y value of your vertex. Okay, so let's talk about finding that vertex again. If we take our two x intercepts, add them together, 2 and -2, 2 plus -2 equals 0. So if I divide that by 2, I'm still getting 0. 0 is going to be the x value of my vertex. That won't always be true. I happen to know that ahead of time is why I made that vertex there. Your vertex can move, just like this one is not at 0 for your x value. Okay, so if I put 0 in though for these two x values, I gotta redo this problem, but I have to put a 0 here and I have to put a 0 here. I'm gonna rewrite this in a different color. So I'll have a -1.8 times 0 minus 2 times 0 plus 2. Remember, I'm putting the 0 in because that's the x value of my vertex. And that will, when I solve this, I'm going to get y. That's what y equals. So I have a -1.8 times, if I have 0 minus 2, I'm going to get a -2. If I do 0 plus 2, I'll get a +2. 2 times -2 is a -4, but I have to multiply it by a -1.8. Hold on to that thought. Even Mrs. Stoffel's got to use a calculator. What? All right, so 4 times 1.8. Are you going to erase me? 7.2. So y equals 7.2. When x was 0. So this point up here is 0, 7.2. How high is this up? 7.2 feet. High. Sorry, me and my camera there. All right, so finding x-intercepts, averaging your x-intercepts, putting that back into the problem where the x values are, solving for y, that's your vertex, using it in a word problem. All right, I'll put some practice problems on for you. Give it a try. Contact me if you have any questions. I'd like to hear from you. Some of you are asking some great questions. Sometime during the week this week, I will probably let you know what some of the common questions are, and I'll just respond to some common questions. Take care.